So we're going to revisit inverses. We worked with inverses back in an earlier unit, so we're going to work with inverses again, but this time we're going to be working with logarithmic to exponential and back and forth between the two of those. So we're going to refresh our memories on how we do inverses. So first of all, the first step is to replace f of x with y. So you'll notice in number 1, it is just y already. There is no f of x, so our first step is already done for us. The second step is to interchange x and y. So I'm going to have x equals y minus 2 squared plus 4. And then our last step is to solve for x. So to solve this one for x, we first subtract 4 from both sides. So you have x minus 4 equals the quantity y minus 2 squared. Next up is to take the square root of both sides, not forgetting plus or minus. And then the last step is to add 2 to the other side. So we'll have 2 plus or minus the square root of x minus 4, and that will equal our inverse. Just a refresher that the inverse notation is the inverse of f would look something like that. And then since in this problem we didn't have a function name, so we just left it as y. And I did include the function notation just for completeness sake. So that would be your answer. So go ahead and try number 2 on your own and come back and see if you have the right answer. So for number 2, I have my final answer as the inverse being the quantity x plus 5 squared plus 3. So we're going to move on to the lesson. So it says we know how to find the inverse of y equals x squared. That's similar to what we just did. But how do we find the inverse of y equals 2 to the x, which is an exponential function? So to solve for the inverse, you would again switch x and y, or interchange them. And if you do that in an exponential, you end up with x equals 2 to the y. And then remember, our third step is to solve for y. Well, this time we have y as an exponent, so in order to solve it, we would eventually have to convert it into a logarithmic form, which leads me to my box here. To solve for y, we would convert the exponential to logarithmic form. Therefore, logarithms are inverses of exponentials. So we're going to go ahead and try the inverses between exponential and logarithms. So for number 3, h of x equals 4, and then our exponent is x plus 3 minus 7. So my first step is to go ahead and switch my x and my y. Well, h of x, remember, is y, so that will now become x equals 4 to the y plus 3 minus 7. Our next step is to solve for y. In order to do that, I need to isolate this exponential. So I have a 4 to the y plus 3, so I need to isolate this. So that would entail having to add the 7. So you'll have x plus 7 is equal to 4, and then our exponent of y plus 3. So now, this is where we ended up yesterday. In order to solve for y, we're going to again have to convert it to logs. If you begin as an exponential function, your inverse is going to be a logarithm. So you know in the end you should have a logarithm. So to rewrite this, it would be log base 4, since that's the base of the exponential, x plus 7, and then that will equal y plus 3. So that allows us to bring the y, which we have to solve for, out of the exponent. And now it's, in order to solve for y, we're just going to subtract 3. So you have log base 4 of x plus 7, and we're going to subtract 3. Now again, that is our inverse, so I'm going to look back up here at the original problem, and our function name is h of x. So when I write my inverse notation, it will be the inverse of h. And that would be your inverse of the original function. So for number 4, fairly similar. Again, switching x and y. So it'll be x equals 1/4 to the y plus 1. Now this one, it's already isolated, so we have 1/4 and then our power, and there's nothing else being added or subtracted. So I'm going to rewrite it. So it'll be a log with a base of 1/4 of x, and that will equal y plus 1. And then our last step to solve for y will be to subtract the 1. So you have log base 1/4 of x minus 1. And again, we only had a function name of y here, so I'm going to write it as the inverse of y. Go ahead and try number 5 and see if you can do it on your own. So for this problem, I have for a final answer log base 5 of x minus 1, and I notice I put that in parentheses, the x minus 1, so I was at least a little aware that the x minus 1 was what we were taking the log of, and that ended up being our inverse. So for number 6, we have to work a little bit in order to be able to find the inverse. You should notice in number 6 that we have 2 separate logs here on the right hand side. So we're going to have to use a couple properties of logs before we can actually find the inverse. So the first thing I want to do is, I notice that I have a coefficient here of 3. So I'm going to use my power property and move that as an exponent. So this would be log 2 plus log of x cubed. Now I want to condense this into a single logarithm, and I notice that they're being added together, so I'm going to use the product property, which indicates that I would multiply. So you have log, and then we're going to multiply 2 times x cubed. So now I have one single log, and I'm going to go ahead and from here we're going to rewrite it so we can find the inverse. Now keep in mind we are starting with a log, so we would expect that our answer to be an exponential function. So we're going to go back to finding inverses, so I'm going to switch my x and my y. So we'll have x equals log 2y cubed. And we're going to rewrite this now. Just a reminder that this is base 10 if it's not indicated of a base, it's base 10. So now at this point the log is isolated, so I'm going to rewrite it as an exponential function. So it would be 10 to the x is equal to 2y cubed. So to solve this for y, which is, remember, our next step, typically you would want to divide by 2. I would just give you a word of caution not to divide by 2. I think it's a little bit easier if you multiply by 1/2. It's very tempting to take 10 and divide it by 2, which you are not allowed to do. So you cannot take 10 to the x and divide it by 2 to get 5 to the x. Remember, order of operations says you'd have to perform this exponent before you actually divided. So you would have to leave it in this form. So we're going to leave it that way. So we're going to leave it as 1/2 times 10 to the x is equal to y cubed. And at this point you have two options. Option 1, you can take the cubed root of both sides, or you can raise it to the 1/3 power. It doesn't matter which option you chose. So for you wanted to make it option 1, might have to squeeze it in here. You'll have the cube root of 1/2 times 10 to the x, or you can have the inverse as being 1/2 times 10 to the x to the 1/3 power. Because remember, taking the cube root, you can rewrite that as a rational exponent of 1/3. So either or is acceptable at this point. Our last couple problems here, number 7, we have f of x equals log base 6 of x minus 2 plus 1. So we're going to go ahead and switch our x and y. So it would read x equals log base 6 of y minus 2, and then we're going to add 1 to that. So we have to isolate the log base 6, and I notice I have a plus 1, so I'm going to subtract 1, so it would be x minus 1, and then log base 6 y minus 2 stays. Once the log is isolated, I'm going to rewrite it from a logarithm to an exponential. So this would read 6 to the x minus 1 is equal to y minus 2. This again takes the y out of the log so we can solve it. And then our last step would be to add 2. So you have 6 to the x minus 1 plus 2 is equal to your inverse. In this case, our function name is f, so I named it the inverse of f for my final answer. We'll go ahead and try number 8 together, and then you can try number 9 and number 10. So for number 8, again, switching x and y, you should notice that we start with an exponential. So in the end form, we should expect a logarithm. So let's go ahead and see what we get. X equals 2 to the y plus 8 divided by 4, so interchanging my x and my y. I'm going to multiply both sides by 4. Remember, we have to get 2 to the y by itself. So that'll cancel the 4's out on the right side. So you get 4x equals 2 to the y plus 8. I'm going to subtract 8. So 4x minus 8 is equal to the y power. And now that the y, the exponential, is now isolated, I'm going to rewrite it. So it's a log base 2 of 4x minus 8, and that will equal our y value, which is our inverse. So we have the inverse of f. So this would be our inverse. Go ahead and take a couple minutes and pause the video and try numbers 9 and 10. Number 10, there are a couple different ways that you can write the answer, so I'll try to come up with as many of the ways that are possible. So come on back. For number 9, I had 10 to the x plus 2, and then that equals your inverse. Just a note that, remember, this is base 10, so if you had trouble rewriting that one, it may have been that you forgot that if a log is not indicated with a base, it is base 10. And then for number 10, I did two separate, I switched x and y, so I did the first step that we were supposed to. And then from there I did two different paths, and depending on what you did first, you could end up with what looks like different answers, but they are exactly the same. So the first method, I divided by 3 first to get the log base 2 by itself, and that's over on the left in the blue. And then on the right, I used the power property and moved the 3 up as an exponent, and then rewrote it. Ended up with the cube root of 2 to the x plus 1. So again, they are actually the same answer. They just look a little bit different.